Okay, so yeah, I am here to tell you that ambition has never been my difficult part. I think we might have found a new tool to end pandemics. And a lot of people believe in vaccines. That's our obvious hope. Good vaccines like polio, yes, but COVID is a quick fix because look, seatbelts, 30% of people don't wear them unless there's a law. Okay, so what we need are automatic virus killing weapons, things that work without any effort, and they have to be silver bullets. They can't hurt people. They need to kill all pathogens in the air, bacteria and viruses of all kinds. Okay, and we need these weapons to work on two battlefields. Outdoor, we have avoidance, so I'm not going to worry about that too much. Mainly, I'm indoor, and really, one of the main we have is ventilation. Open the windows, dilute the viruses. Okay. We have a couple others. We can spray and wipe surfaces. If you go in retail, you won't, that's passive. You don't do anything as a shopper. And then in the ducted air, we've got a few tools like this UV light that kills pathogens, all pathogens in the air. But what we don't have is a way to kill droplets from this guy to that girl. It takes about a third of a second, typically, for a droplet to fall on her. And we don't have anything much we can do about it. Ventilation and airflow. Except that this year we found a possible silver bullet, 222 nanometer, 222 UV light, safe for skin and eyes, unlike almost every other kind of UV. It's going to get FDA approved this year. It's already provisionally approved, and it comes from Columbia University. And so it works in the lab. What I'm interested in is seeing it work in the field, like this gymnasium. And it's much harder than a lab setting. They've only tested certain droplet sizes, airflow, there's a lot of things. And so what we are going to do is build it and see. We've got a gym in DC that's agreed to let us do trials. We're going to install lights. We're going to change their airflow, and we need efficacy sensors. That's one of the big things that we're really excited about is detecting. Okay, this isn't going to be cheap. So, but the lockdown, losing their customers, cost the gym more. So even if it costs $12,000 to $100,000, we reckon that is a price that's a good deal. So if it works, our plan is to install it everywhere, create a $25 million new industry. And compared to the tech, that's actually the hard part in my view. And that's where I'm really focused is how do we get this to roll out at a global scale? So that's what Farlight does. Farlight is a startup that I'm exploring, proposing. And its mission is basically, what you can guess. We're doing it as a pro-social consultancy. I'll explain a little more about that. What would be a big enough carrot to make the world change? 50% occupancy law is currently what's being in place for post-lockdown retail. They're losing half their money. That is huge. That is way bigger than 10 billion across the world. So we were going to try to get that occupancy back by making their spaces safe. We're going to use open source disruption, and we're going to empower. So it's a carrot and stick model where for retail, or let's say a contractor, we're going to say either you get on board or or you're going to get left behind. And so can this be done from a hardware side? Yeah, there's a giant company, Ushio, that's making the lights. There's lots of other people making equipment. But what's missing are the installers and certifiers. Because this is hard. It's like installing an elevator. You need a unique design for every building, and it needs to be carefully monitored and rigorously inspected to make sure it's actually effective if we are going to allow people in at full density. So yeah, I've got 4 people that are amazing, and it is nowhere near enough, and we really could use help. So we want you, the point of this presentation to me is to try to attract people who actually know this space. Thank you, and good night.
Thank you.
So I guess
so at the bottom of your screen or somewhere on your screen is a thing that says participants. If you click on that, I believe that's how it works. If you click on that, I think there's a place for you to raise your hand. So if anybody has a question for Josh, raise your hand. If that isn't working, just waggle your hand like this, and I'll call on you. Questions? Adina, I'm unmuting you. trying to. There you go.
So
Hi,
I
Nina.
guess my question, hi, and you might not know the answer, I'm just kind of curious, is I know that when we kill all of the bugs around us and viruses and bacteria, we also create some new problems biologically. Like studies of like one of the reasons why our allergies are worse in like super pristine environments versus other environments, etc. Do you have any information or ideas on that or thoughts?
No, I don't know how the impact would be. But remember, we're talking about killing the air in a retail space, not in all of the world. So when you
Okay.
walk in Target, the air is clean. When you walk outside, it's normal air. Yeah, that's the short answer. I'll go all day, but I'll wait for questions.
And Brad. Wait, you're still muted. One moment.
Space bar.
There you go.
Am I unmuted?
Yes, you are.
Yep.
Right.
Hey, Brad.
Okay. My question is, with ultraviolet light, we know that we can create ozone among other problems. My first question is not efficacy but safety. The sense that this particular region of ultraviolet distributed everywhere, is that really safe? That's my question.
We have
Evidence of
8
safety.
years and dozens of studies on animal. The answer is we think it is. The FDA thinks it is. I think it is. But we don't really know yet. And that's a huge part of our study. So we do have a few human trials. We have lots of animal trials, rats, skin
I didn't
and
understand
eye.
that.
Okay. You can hear me though, right?
Yes.
Okay. So there has been a lot of study on safety. That is the most people's first question about this. The answer is we don't have as much proof as I want, but every bit of evidence we have says it's very, very safe. I've got a few slides and I can talk about that more if other people are interested, but yeah, it is different. And just on the ozone, it doesn't generate, the lights that we have don't generate ozone like a lot of UV does.
Good.
Yes.
Thank you.
Yeah, keep going though. I'm happy to answer more questions on safety. Keep pressing me.
David, you were muted.
Thank you. Chris has a question, and I'll ask him to unmute himself. You're still muted, Chris. I can't hear you.
Press the space bar.
Hmm.
Can you hear you, Chris?
Can't hear you, Chris. Sorry.
Sometimes if you mute and unmute a couple times, I don't know why, but that seems to do something.
I'll check. You can,
I'm gonna go.
if you want to type it in, Chris, I'll just read it out.
Yeah, type it in the chat and we'll go from there. Meanwhile, Bruce had his hand up. Bruce, you can unmute yourself.
Is that unmuted?
Yes, you are.
Yes.
My question is transitional. I can understand that if every building in the planet had your equipment, the inside would be safe. But getting from there to here has several issues, not the least of which is legal. Would your program include liability insurance for a company that buys your product, but someone who comes into their establishment gets a virus, doesn't know where they get it, of course. It only takes one unprotected place for them to get the virus. How would you work that transition?
Yeah, it's a great question, Bruce. So what we are planning to do is pull together a coalition of ambitious people, including people from the insurance industry. And I am very concerned about property owners' liability insurance. So we need help to answer that question. I don't have a good answer. I am concerned about it too. I do think could be a major barrier. I need a legal expert and an insurance person, and I hope in a couple months' time we can give you a better answer. If you know anyone, please connect me. So I saw Chris's thing. Should I read it out?
Yeah, go ahead and read his question.
Sorry?
Yes, go ahead and read his question.
Okay, so Chris asked, LiDAR and self-driving cars, is eye safe? It can destroy high-end digital cameras. Would UVC cause fading in hair, cloth, and paper, etc.? Yes, it could, but so far, there are certain kinds of materials that will get some damage. We think if the dosage is necessary, it won't cause a lot of damage, but that is exactly what a field trial is for. What will this do to the vinyl in the gym, the plastics on the thing? It is very different. It's very, very delicate. My engineer buddy calls it a feather duster compared to other kinds of UV. So that's very thin layer. A single human cell stops it. It can't penetrate the outer dead layers of your skin or even the top layers of the cells on your eye. So it can't penetrate much at all. So we'll have to see. But we don't know. We have some reason to hope.
Any other questions? Renata, you may unmute yourself.
Do you know what your timeline for this, like assuming that you get somebody, let's say you got somebody now, what would the timeline be before it could be used, put into place?
Well, we think we can test within 30 days of getting our agreement. We have suppliers for lights. Our biggest holdup is the design of the test, getting somebody who designs human subject studies involved. The lights are reasonably safe in terms of the worst case outcome is temporary irritation to skin and eyes. And that's if it's, we don't think that's going to happen because the tests have shown that skin and eye contact is, even at very high doses, there's no reaction at all. But if we use the wrong kind of UV, for example, like 254, our lamps aren't working right, it's still not permanent skin cancer stuff like you get from the sun. Like it's still not. So anyway, like I said, the FDA has approved it for direct contact on people in medical settings. That's the current level of approval. And we expect 6 to 9 months to get full unlimited approval. So, as you know, FDA is pretty damn rigorous. That's a pretty high bar they usually set for stuff like this. It's new. We don't know. We're definitely out in the outer realm of proven. So this is not ready for prime time. What we're proposing is to get it ready for prime time as fast as possible.
A question from Ocean and then back to Jamie. Ocean, you want to unmute yourself?
Indeed. Yeah, I was actually just going to ask about the FDA, time to approval. It's interesting that you have a timetable. I'm curious, are you basing that on other sort of similar technologies that have been moved from medical approval to general approval, or where does that time frame come from? And then the second question is,
it comes from David. Oh, sorry, go ahead.
No, you can go ahead.
No, okay. So yeah, timeline comes from David Brenner at Columbia University. His estimate is 6 to 9 months for full FDA approval. That was regardless of COVID. And now we have an emergency approval from COVID. The FDA is really keen to anyone who can still COVID, anyone who has a device that will kill the vaccine in a medical setting. They are reducing the bar for those people, and that includes this, obviously.
Gotcha. And then the second question was, you said you're working on basically making this happen. So just real succinctly, exactly what do you need to make it happen, to get started with it? And then what's the timeline that you're kind of looking at?
We need some cash around $10,000 to $40,000 to buy the equipment. We need some experts, like I said, some study design experts and installers. And then we need, like Bruce mentioned, some advisors at least in the liability and the both legal and insurance type settings. That's kind of for later. For our trials, we don't need that because we already have a site. We have a person who said, yes, come install this in our gym. And, so mainly it's experts who can detect sensors and some cash to do it all. And our timeline roughly would be like 3 months, I would say. I think that's a realistic timeline. We could do it in 30 days if we're lucky.
So I hate to, I don't mean to monopolize the time, but just real quickly, are you looking for investment or are you looking for donation? Like what's your financial model that you're thinking about?
Either. So we, I think for $4,000 we're looking for donation, and for $40,000 we would be taking investment. It's a pro-social B Corp. So we expect our investors to be pro-social, which is to say, we will give your money back and make you a lot of money, most likely, but all of us want to stop COVID, and that's our primary.
Totally. Thank you.
And Jamie, you had a question?
Yeah, so my question is, how does efficacy-wise, so efficiency-wise, how does this approach compare with other kinds of maybe more common approaches like advanced air filtration systems that would already be built into HVAC systems, things like that?
Right. We see this as an addition to those. So the answer is we run all of them, but this does one thing none of those can do, which is it can kill the virus before it lands in someone else. None of those other systems do that. The best we can do is airflow direction, where you blow a bunch of air past the person talking and get those viruses up above them, so the droplets don't land. And that only dilutes it. The ceiling on the effectiveness there is, not as high as we want. Is too high. I didn't say that right. It's not very effective, is what I'm say.
Very good. Yafa, you have a question. Go ahead and unmute yourself. I think I just did it, or one of us did.
So you said that they're already doing something similar in the lab. What's different about what you're doing other than scale?
Oh, it's in the lab. They made a little plastic tube and ran from one mouse to another mouse, an infected mouse. So they had two boxes. These mice were infected. A little plastic air tube connected them, and these mice got infected. And then in the tube, they ran this UV light, and it killed all the viruses in the air. So these mice didn't get infected. So it was proof of concept, but the mist in the air was not exhaled from the mice. It was manufactured. So there's a million things different between a gym setting and that, right? So, yeah.
Like there's all those like water purification UV things. Is this in the same sort of group of things for that?
There's a whole bunch of existing UV purification, and they can't touch human skin. They cause irritation, and what's called welder's flash. They're 254 nanometer. This is 222 nanometer. It seems like it should be a small difference. It's a huge difference. That wavelength cannot penetrate a human cell. It can penetrate virus and bacteria cell. It's this like magic bullet wavelength.
And any last question before we go on to the next? Brad.
Hi, I was thinking through how you would test this in humans, and it's going to be very hard. You need to have a population that will be expected to get COVID. You need to do your process, then it goes down. You need to take your process out, then it goes up. Finding that kind of population to me sounds really difficult. It depends on how loose the FDA.
The FDA is very loose, and one of our test sites is retirement centers, and multiple owners of multiple retirement centers. Put them in one, don't put them in the other. And those people are like, it is a freaking nightmare what's going on in there right now. So we can, the harm that our risk of giving somebody skin irritation versus them dying of COVID, the deal is really clear. Like, I feel good ethically about running this in those settings. So,
So you do seem to have a
that's one
population
example.
that's pretty much guaranteed to get COVID, that you can measure that level and then with your process see it go down. That's
Retirement centers are that. You're right, and retirement centers are that. So right now, there's the infection rate in retirement centers and hospice and those kind of long-term care facilities is really, really bad. So we will definitely see people getting sick without our treatment. If we have center A with our treatment, center B without, it's pretty simple.
Perfect.
Another question in the chat from
just
Chris.
the comment that you don't want different centers. You want the same center plus or minus.
Yeah, that would work too. But but ours is quicker if we run them in parallel.
Chris, did you have an additional question?
Yeah, the question is in the chat. I can read it.
Okay, got it.
What about the effect on VOCs, which means volatile organic compounds, and can it make them more dangerous or less dangerous?
I don't know. I dimly recall reading a paper on 222 helping prevent VOCs from being dangerous, but I'm not gonna, I'd have to come back to you on that.
All right. Thank you, Josh. Everyone give him a hand.
My pleasure. Thanks, guys.